Have you ever wondered if we could predict earthquakes? It's a question that has captivated the minds of scientists and civilians alike, driven by an innate human desire to protect ourselves and our world from the devastating effects of natural disasters. Earthquake studies are as old as civilization itself, but it was only in the 20th century that we began to truly comprehend the Earth's tectonic movements. This understanding dawned with the theory of plate tectonics, revealing that our planet's crust is made up of massive plates that shift and cause earthquakes along their borders. Since this groundbreaking discovery, we've made monumental progress in monitoring these plates and detecting pre-earthquake signals. Yet, the precise prediction of an earthquake's when and where continues to elude us. Although we've made strides in understanding Earth's tectonic movements, predicting exactly when and where an earthquake will occur remains a challenge. Why is predicting earthquakes so challenging? Well, to understand this, we first need to know what causes earthquakes. They occur due to the movement of the Earth's crust, which is divided into large plates. These plates shift and grind against each other along their boundary lines, and sometimes this movement causes a release of energy that we experience as an earthquake. Now, imagine trying to predict such an event. It's like trying to predict when a rubber band will snap when you keep stretching it. You know it will break at some point, but exactly when is hard to tell. And that's the crux of the matter. The geological processes leading to earthquakes happen over enormous temporal and spatial scales, often starting kilometers below the Earth's surface in extreme conditions that are difficult to replicate in the lab. You'd think that there might be some signals, some warning signs before a major quake, right? And indeed, sometimes there are. Small changes in the physical properties of rocks or minor foreshocks might precede a big earthquake. But here's the kicker. These signals are not consistently detectable, and they're not universally applicable to all geological contexts. So, what might be a warning sign in one place might not mean anything in another. And that's what makes earthquake predictions so complex. We're dealing with a natural event that's the result of processes happening deep within the Earth, over vast scales and under conditions we can't fully replicate or observe. It's like trying to predict the exact moment a storm will hit based on the behavior of a single cloud. Yet, despite these formidable challenges, we're not in the dark. Significant progress has been made in understanding and monitoring seismic phenomena. We are learning more about the Earth's crust, about tectonic movements, and about the signals that might precede an earthquake. Despite the challenges, progress continues to be made in understanding and monitoring seismic phenomena. And with each new piece of information, we're getting closer to the goal of predicting earthquakes, of protecting ourselves and our societies from these devastating natural events. How has technology aided our understanding of earthquakes? A question that echoes in the corridors of scientific inquiry, and the answer is quite remarkable. The advent of technology has indeed revolutionized the field of seismology, providing us with invaluable tools to monitor and understand the mysterious, often devastating phenomenon of earthquakes. One of the key advancements in this field is the global network of seismic sensors and GPS. These instruments, scattered across the globe, tirelessly keep track of the Earth's crust deformations. They act as our eyes and ears, observing the subtle shifts and movements that occur beneath our feet. These movements, though often imperceptible to us, can provide critical insights into the tectonic processes that lead to earthquakes. This real-time monitoring of Earth's crust is a game-changer. It offers a continuous stream of data, painting a dynamic picture of the Earth's tectonic activity. This data is not just numbers on a screen, it's a lifeline, a warning system that can alert us to potential seismic events before they happen. A prime example of this technology in action can be seen in the land of the rising sun, Japan. Here, advanced early warning systems utilize the data from seismic sensors and GPS to provide alerts seconds or even minutes before the arrival of seismic waves. These precious moments can mean the difference between life and death, providing people with the time they need to seek shelter and secure their surroundings. These systems, however, are not infallible. Predicting the exact when and where of an earthquake remains a complex challenge. Yet, The strides we've made in monitoring and understanding the Earth's tectonic movements are undeniable. We've come a long way from the rudimentary seismographs of the past, and our technology continues to evolve, driven by the relentless pursuit of knowledge. These advanced systems are testament to the progress made in earthquake monitoring. They represent the marriage of technology and science, a union that continues to push the boundaries of our understanding and capabilities in the face of nature's most powerful phenomena. Are there other, less conventional ways to predict earthquakes? Absolutely, and that's where some of the most exciting research is currently taking place. Scientists are now exploring geochemical, hydrological, and even biological signals that could indicate an impending earthquake. Let's dive in. First, we have geochemical signals. Some researchers have noticed that changes in the levels of radon gas, a radioactive substance naturally present in the Earth's crust, could precede seismic events. Radon has the ability to seep through cracks in the ground, and these cracks can widen or multiply when tectonic stress increases. Hence, a spike in radon emissions might hint at an upcoming quake. However, the correlation is not straightforward, and more research is needed before we can use radon levels as a reliable earthquake predictor. Next, there's the realm of hydrology. Scientists have observed that groundwater levels can fluctuate due to the strain in the Earth's crust before an earthquake. Sometimes, these changes can be seen days or even weeks ahead of the event. However, like radon, these signals are not always consistent and require further study. Finally, we have biological signals. You may have heard stories of animals acting strangely before an earthquake. While these accounts are largely anecdotal, some researchers are taking a closer look. They're studying whether animals can sense impending earthquakes, perhaps through subtle vibrations or changes in the Earth's electromagnetic field. However, this field is still in its infancy, and it's far from clear if or how we could use animal behavior as a reliable quake predictor. These unconventional predictors offer fascinating glimpses into the complex world of earthquake forecasting. However, it's important to remember that none of these methods are foolproof. Each comes with its own set of challenges and uncertainties. The signals they provide can be inconsistent, their interpretation is often ambiguous, and not all earthquakes announce their arrival in the same way. While these signals offer a new avenue for prediction, their reliability is still under investigation. Could artificial intelligence be the key to unlocking earthquake prediction? This question is at the forefront of many minds in the field of seismology. As we move forward in this age of digital revolution, the potential of artificial intelligence in predicting earthquakes is being explored with great interest. Artificial intelligence, or AI, is a technology that allows computers to learn, reason, and make decisions in a way that is similar to human intelligence. In the realm of earthquake prediction, AI has the potential to analyze vast sets of seismic data, identifying patterns that might otherwise be unrecognizable to the human eye. Picture this: hundreds of thousands of seismic events happening across the globe, each producing its own unique pattern of seismic waves. Human analysis of this data is not only time-consuming but also limited by our cognitive capacities. Enter AI, with its ability to process and analyze large amounts of data quickly and accurately. AI can sift through this sea of information, identifying patterns and anomalies that could potentially indicate an impending earthquake. But it's not all smooth sailing. While the potential of AI in earthquake prediction is immense, there are still several hurdles to overcome. First and foremost, the accuracy of AI predictions is dependent on the quality and quantity of the data it's trained on. In regions where seismic activity is low or not well monitored, the effectiveness of AI predictions may be limited. Moreover, AI models are generally black boxes, meaning their decision-making processes are not entirely transparent. This opacity can make it difficult to understand why a certain prediction was made, making it challenging to improve the model or to validate its results. Finally, while AI can identify patterns in data, it's still up to human researchers to interpret these patterns in a geologically meaningful way. This requires a deep understanding of the Earth's processes and a careful consideration of the limitations of AI. While AI shows promise, it's still early days in its application to earthquake prediction. Yet, the potential of this technology in helping us understand and predict earthquakes is undeniable. As we continue to refine these tools and expand our seismic datasets, we may be inching closer to the long-held dream of accurate earthquake prediction. So, where does this leave us in the quest to predict earthquakes? We've journeyed through history, from the ancient roots of earthquake studies right into the heart of modern seismology. We've witnessed the strides made, the challenges faced, and the relentless pursuit of understanding that fuels this field. The ability to predict earthquakes accurately, while still a lofty goal, is inching ever closer thanks to the tireless efforts of the scientific community. The road ahead, though steeped in complexity, glistens with promise. Each new discovery, each technological advancement pushes us a step closer to our goal. The more we learn about the Earth's tectonic movements, the better equipped we become to protect ourselves from their devastating effects. The focus now is on continued research, on harnessing the power of artificial intelligence, and on building more resilient societies. The dream of predicting earthquakes with accuracy remains alive, bringing us ever closer to turning it into reality.